welcome to the webinar. My name is Josh McDaniel and I work with the Wildland Fire Lessons Learned Center. And in a few moments we'll start the webinar, but as usual I want to give a few quick announcements. First off, I want to recognize the supporting organizations for the webinar series. There's the Wildland Fire Lessons Learned Center. There's also the Joint Fire Science Program and International Association of Wildland Fire. And I've put some links up here. Encourage you all to check out their websites. All three of these organizations are doing great work, and you should take a look at what they're doing. Next, I want to point out, announce the upcoming webinars. The next webinar that we have on the list, and there are a few more sort of in the works, but on November 20th, Esther Godson is going to be giving a presentation on new developments in mobile technologies in fire and aviation management. And I've talked to Esther about this a few times, and there's some exciting new developments in mobile technologies, and a lot of this is coming straight out of the field, so I encourage you to sign up for that. And you can register on the Advances in Fire Practice page. There's a link there, or Google Advances in Fire Practice, or navigate to Advances in Fire Practice through the Wildland Fire Lessons Learned Center menu. Okay, and now on to today's webinar. I'll introduce the speaker in a second, but I just want to let you know how questions work. I encourage you to get questions in early. The top ones in the queue get answered first. So write in your questions box. Some of you it may be a chat box, depending on what platform you're on. Just type your question in, and at the end of the presentation, we'll have a question and answer period, and we'll read those questions out and get the speaker, Stacy Drury, to respond. Okay, also the webinar is being recorded, and it takes an hour or so after the webinar to load the recording to the Lessons Learned Center's YouTube channel, but we'll have that link available as soon as possible, and you can pass that on to anybody you think might be interested. Okay, so that should take care of the housekeeping. Now I'll introduce Stacy Drury. Stacy began working in fire research in 1992 as a field crew member for the Pacific Northwest Research Station in Seattle. While with the Pacific Northwest Research Station, Stacy worked on a number of fuel consumption and smoke exposure studies in the Pacific Northwest and Alaska. From there he moved on to the Fish and Wildlife Service, where he worked on a fire history study within the Yukon Flats Wildlife Refuge in interior Alaska. And in '99, Stacy left the Fish and Wildlife Service to complete his PhD at the University of Colorado Boulder, where he studied fire history in the Sierra Madre Occidental Mountains of north central Mexico. In 2007, Stacy joined the Missoula Fire Lab, and with the Fire Lab he participated in the Ecosystem Management Decision Support System, or EMDS project, and conducted research using the Fire Harm Modeling Platform. Stacy joined his current employer, Sonoma Technology Incorporated, in 2009, and does not have any plans to go anywhere soon. Okay, so with that, I'll hand it over to Stacy.
Oh, thanks.
Here we go.
All right, I'm going to show my screen here now and start from the beginning. I guess I should put a little caveat on why that comment is. I'm not planning to go anywhere soon, as my wife said we weren't going anywhere soon. So I'm very happy with where I'm at, and I'm really happy to be here talking to you all today about the Interagency Fuels Treatment Decision Support System. I call it IFT-DSS, but its nickname is IFT-DSS, and it's a project we've been building for the last 3 years. I've been involved since 2009, and the JFSP, along with Mike Rauscher, started in about 2007. So I want to put it into context here about this talk. Right now, we have so much stuff in it that I can't show you everything that's in it, and we have a saying around here at STI where we refer to it as a sandwich, not a picnic. And to extend that analogy, what I'm going to present here is a finger sandwich, or an appetizer, if you will. But I really want to encourage you to take the opportunity and get into the system. Hopefully this will give you some reasons for wanting to join in and get in and look around and beat on it. I'll provide you with some links to where you can get an access code from me and get into the system and drive it around, beat it around yourself, and see what's there for you to use. So that said, I'm going to give about a 20-minute PowerPoint, might be a little less, give some of the background on why we're doing it, what we're doing, and then talk a little bit about how the system is structured around workflows. Then I'll give a live IFT-DSS demonstration. Now, one of the things I want to point out is I'm opening up the hood right now and showing you some of the functionality that it's in our upcoming 2.0 release. Our system is a developing system, so I guess you could call it beta, but sometimes I'm not sure if I'd want to say beta. But we're working on right now getting out our 2.0 release. We've got myself and the other science person running around with the software engineers, finishing up a lot of the functionality that we're going to release in 2.0. We should have that coming out here in the next few weeks. So I encourage you to get on now, but you will be looking at the 1.1 that's on our public server. I'm going to be showing you something under the hood on our development server. And that said, it's always scary to be showing the development server. I just ran through everything and it worked fine, and nobody's supposed to upload any new changes or fixes in the next hour. So anyway, and I'll show you when I got the getting started, and the help here is I really want to show where we've got things positioned so that if you get in, you can go in and look at videos we have in there, tutorials, guidelines for how to use the system to provide outputs that you may find useful when you're doing planning. Show you the tools we have in the system. I'll do a quick run through a Landfire data acquisition, and if any of you have used Landfire, you know that they've made some big improvements in the last few years on how you get data out of Landfire, but hopefully you'll really like what you see, because in my opinion, we've made some real big improvements on that to make acquiring and using Landfire data much more feasible and acceptable. Then I'll run on the Landfire data that I acquire. I will take and run a FLAM map run, so I'll give you a little bit of a spatial fire behavior run. I'm going to run through the risk assessment, which is a new risk assessment process that we have developed based on Alan Ager, Mark Finney, and Dave Calkins' work over the last few years. And then, if time permits, we'll look at some of the burn plan template building functionality we have in this system. And we've just had a meeting last week where we're working with a number of folks, including some folks from the Fuels Management Committee, to refine and produce more official type burn plan templates. So looking at how the different agencies and different folks are using it. So we've got a lot of things going on, a lot of balls in the air, but doing some really cool and interesting stuff, and I hope you like it. All right, so this project, the IFT-DSS project, came out of a JFSP project called the STS, or the Software Tools and Systems Study. And the problem statements, so the things that they found, the issues that they were looking at addressing, was that there was, over the years, a lot of software had been developed, and some of it was overlapping, some of it was redundant, some of it did one thing and not another, so it was fairly unconnected, as is written here. And people were spending a lot of time learning how to use it or relearning it if you used it for a week or two every year, and then transforming, acquiring, analyzing, looking at the data, trying to figure out what exactly they were using. There was a lack of an analysis framework and just a lack of consistency throughout this profusion of software systems. And then the lack of data on model performance, found that it was expensive to maintain all these systems, and there was no framework for governance. So for many folks that are looking at fuels treatment planning, some of these issues might not be as important to you, but from a higher up level, these were some big concerns. And so they looked at how do we start addressing some of these concerns. And that's where the IFT-DSS project was first initiated. And they went through and they said, okay, well, how do we build a tool that helps us connect some of these things and provides a need? And they looked at the business needs that were out there, and they found that fuels treatment planning was an area that was rising in importance, and there was just not a whole lot out there to help fuels treatment planners do their job. And so this is a kind of virgin territory. This is a good place to test out how we would build a system, a decision support system that would help us move forward. And so some of the key things they found out when they first did this study, and this is before I joined the project, was that fuels treatment planners are responsible for managing vegetation. That might seem like a no-brainer to many people, but it was a kind of a step forward in a lot of ways, because we think about fuels in some ways as a little apart from actually managing vegetation. So the key point in this managing vegetation is it's around modeling vegetation disturbances, fire, bug kill, things like that. So things that influence the fuels that are available to burn. And then we start looking at the decision support process and say, okay, where do you start? Well, you start with, what is my project? Where do I want to burn? What kind of fuels in terms of vegetation and landscape scale? How big am I thinking about 10 acres, or am I thinking about 5,000 acres? Or do the planning needs need to be at bigger scales? Take a look at, what kind of data do I have? What's the quality of the data? How do I, if I'm not happy with the quality of the data, how do I take and ensure that that data actually represents what's on the landscape I'm managing? And then what are the tools to analyze fire behavior, and which tools would be appropriate for use in different vegetation types? Same kind of thing with fire effects, so looking at fire effects. And then what's the risk that I'm going to burn? Or if it does burn, is there a value loss? Is actually burning a benefit? And then once you kind of come through all of those processes where you go through and set up your project, how do I treat the area in a way that makes sense, that gives me the results that I'm looking for? And once I'm able to simulate that treatment that I've decided is appropriate, how do I judge whether or not the objectives of conducting this particular treatment were effective? And there was a long, lengthy, I don't know if I'd say long, a thorough evaluation of the different models that were out there and whether they were serving the purpose that they were developed for. And it came up that a lot of these assortment of data and tools that were out there weren't all acceptable to everyone. Some people can't load things on their computers. Some people don't have the correct access to different data sets. So trying to address some of those things, that not everything is accessible. Some are built to answer a specific problem, like estimating PM 2.5 emissions, but they weren't very comprehensive. And then it was difficult to use them in any kind of a sequence. So people were developing ad hoc ways of, well, I use this tool to do this process, this tool to do another process, but it's really hard to connect them together in a coherent fashion. And for the fuels treatment community, that meant that people saw all this information. There wasn't a lot of guidance on which models to use. They don't often have a lot of time to use these different tools, and so they wind up using what they know, which, as you see here, if you look at this red bar in the graph on the right meant people use behave. And I don't know how many times I've heard people say, I'm really interested in all these other tools and I'd really like to look at how fire may be simulated across the landscape that I'm interested in, but I only have a short amount of time to do this planning. I start looking at how much work I need to do to acquire the data, process the data, then run it through all the models, interpret the data output, and in the end I say, I don't have time to do all that, and I know behave's easy to use. I understand its pluses and minuses, and so I just go to behave. And so we use that information we got to evaluate which tools we should put in IFT-DSS first, because we're geared for providing the tools that managers are using in a meaningful way and then hopefully move them to use more of these additional tools. So you can see that we quickly worked. It was a bit of a struggle to get it in, but we went and worked and we got behave in, and in terms of its underlying algorithm. So we don't have behave plus. We have not incorporated behave plus literally, but we have the algorithms and the functionality that are in behave plus. We have FOFM and FlamMap. You can see a lot of the data sources, Landfire. We're using a lot of functionality from different tools such as ArcGIS. We're not trying to replicate or curate a new ArcGIS, but we have some basic mapping tools that we feel would be useful to the land manager. And so that gets us into what are the real objectives. So we've got these tools, we've got some problems, but the real objectives are to make this system usable. Simplify the process of getting at the data, improve the usability of a lot of the different underlying models and module algorithms while not dumbing down the science. We want to improve the overall quality of analysis and planning, but provide new opportunities for people to look at their landscape perhaps more spatially, or do some game playing and a lot more evaluations of different scenarios, and then encourage people to collaborate while keeping that within this idea of controlling long-term costs. And since it's an online system, you don't have to worry about connecting to your agency administrator to get IT approval, and all agencies can use it as long as you have an internet connection. So, BIA can be using the same kind of information that the Forest Service is using. And that said, the IFT-DSS is built around the idea of projects, workflows, and runs. But the workflows are the heart of the system, which are intended to capture the problem-solving needs of the fuels treatment analysis and planning community. So what kind of business are fuels treatment planners trying to do? And we got this from a group that was put together by JFSP and the Fuels Management Committee. A bunch of fuel specialists that said these are the kind of jobs that we're trying to do. And then we want to provide tools in a way that makes sense. And we've come a long ways on this, and to stepwise guide you through so that you can get back into the mode of using the model much more simply than if you've been away from it 6, 8 months, 2 years, whatever, and have help in things within that system where when you get to it, not just sitting there rubbing your head and looking at a blank screen, but you can go somewhere and get some insight into what you want to do next. And then provide the support on the interpretation of the scientific model output. And these last two are really the part we're working on right now with in-house, but also with others, like trying to bring groups in such as the Research and Development Group, or DNA, and Fuels Management Committee, folks at different levels within the different systems. We're constantly looking at trying to get people to provide us criticisms, input, insight into how we're looking at these systems. And so the actual workflows are grouped into 4 basic workflows right now. We've variated between 4 and 6 at different times, but we've got it down to this group of 4: hazard analysis, risk assessment, fuels treatment, and prescribed burn treatment. And it can be argued that prescribed burn planning is just another fuels treatment, but we had enough input from land managers saying that prescribed burn planning is such a big part of our overall planning process. Any tools that you can give us on that will help. And so all of these ideas can then be used interchangeable. They're not, these workflows are not meant to be mutually exclusive. You can use bits and pieces and tools from these in any of the planning documents that you're preparing. All right, so just a real quick run through of each of these, and then I'll get into the live demo and show some of these tools. But the hazard analysis, we're really looking at this as a spatial identification of where on the landscape do you have areas that have higher potentials for a hazardous fire. And the hazardous aspect can be set by the user based on rate of spread or flame length or tree mortality, some variable such as that. Right now we've been pretty much restricting it to fire behavior rather than fire effects, but we're working towards the fire effects. And within the hazard analysis, you can now run a flam map basic, so every pixel gets hit by a head fire. You can use the RANDIG tool, which provides a burn probability based on the likelihood that an ignition will happen. So it's not identifying fire occurrence, so it's not giving any indication of the probability of the fire occur. But given that a fire occurs in the landscape, what's the likelihood that that part of the landscape will burn? And then, as you see in this bottom figure here, we've implemented the FlamMap MTT growth model or module, and this gives you some insight into where fire may move across the landscape and how you might want to put treatments in there to mitigate the movement of that fire across the landscape. We've got risk assessment. We're using this, as I mentioned at the beginning, based on the work by Alan Ager, Mark Finney, and Dave Cocken on risk, so evaluating hazard and risk. And we're looking at trying to say, okay, based on what the user knows about their landscape, how do you spatially identify the places where fire on the landscape might be a good thing and places where fire on the landscape is not desired. And again, it's based on these Cocken cost-benefit response function, and I'll show you a little bit more about that in a minute. Fuels treatment is what we're working on right now. It's one of the things that I'm really getting excited about, and there's a number of different things. So we got tools in there such as the FVS and Landfire, a number of different data sets where you can define and evaluate a treatment strategy and simulate, well, based on the best available science, will that treatment accomplish what I am looking at, what my desired goals are. So you define what your goals for putting the treatment on the landscape are, and then utilizing some of these tools to evaluate whether or not that strategy works. Then locating treatments across the landscape, so putting those treatments across the landscape and seeing whether or not they work, how long they last, and then evaluating the spatial influence not only within the area that's treated, but how does it influence the spatial area where you can't treat? Maybe it's too steep or wildlife habitat or something like that. So we're really trying to think holistically about how fuels treatment might go onto the landscape. And this is a pretty exciting part of where we are right now. Okay, and then the prescribed burn planning, we've got some tools in there to allow you to develop your prescriptions, enter them into a template, and then produce the template as a Word document. And I'll show you one of those Word documents. And we've based what we're doing right now on the old interagency prescribed burn planning guide. We have not incorporated the new guide yet, and as I said, I had some discussions with some of the FMC members a couple weeks ago and on some ideas on how to do that, and the RX 341 course. If anybody's taking it, you can see the Red Bull as one of the prescribed burn plans that they do within that. And then using the standard point tools for point modeling, such Behave Plus, things that I'll show you, the Behave modules, and also looking at some mapping. So right before I kick into the live part, this was produced 2 weeks ago for a big meeting we had in Boise. We had at that time 268 registered users. A lot of them, as you see, had got into the system, looked around, but hadn't really done, hadn't conducted any runs, hadn't done any analysis. But 153 people have went through and used it to do some work. And so we're pretty stoked about how much interest we've had in the system, and we've got people in there every day, and this is without much advertisement. We've been pretty much trying to keep our heads down and working hard on providing the tools that people need, and haven't gone out as much as we'd like. We're going to start doing a bit more of that here in the future, so some of you may be contacted. But this particular number, 268, is already, how do I say it? It's already inaccurate because I had about 10 to 15 people since the meeting was announced asked to join the system. So I encourage you to get on. I'm going to provide the access to the public server once we're done with this webinar, and you can get on and beat around in it, ask me questions. I'm excited to be able to do that. Okay, so I am going to exit out of this particular set of slides, and I'm going to open up the live part of the demo. So I got my fingers crossed here, as like I said, as I'm on the development server. The public server is stable and works well. This is also stable and works well, but still kind of, gives you a little bit of fear once in a while that it's not going to work. So this is the welcome page that you come. You can see here, if my mouse is showing up, there's a video where you can go in and watch and get some information about getting started. If you do not have an account, what you need to do is click on this and request an account. What happens when you do that is your email is sent straight into our database here at Sonoma Technology in Petaluma, but I also get an email directly, and I try to respond as soon as I can. Sometimes if I'm traveling, it might take me a day or two Eventually this will be automated, but as I said, we're a beta system, and I'm the manual account request granter. And I'll send you an email. I'll send you a code that'll allow you to get into the system, and then you can use me as a point of contact for any kind of problems you have. And you can see here we've got some script on what's new and what version. So I'll log in now. See, I got a number of different sites. Once you log in, you'll be asked to create a profile, and I've got a profile here. You can see I was kind of lazy when Josh asked me for a bio, and I basically just gave him the information out of here. Also, you can put a picture, and you don't have to if you don't want to, but you can put a picture of yourself. A lot of people put pictures of their pets. But what I want to show mainly on this page is if you go along one of the first places that you might want to click is on the help, and you can open up the help that applies you or opens up in a new tab the fairly elaborate help system that we've developed, which has things such as explain the concepts, how the IFT-DSS is organized, what happens as you set up each of the projects. But you may be just more interested in getting going. And there's a number of different tutorials and videos, and we've based these tutorials, for example, prescribed burn plan tutorial, on how to walk you through, say, preparing a burn plan document using IFT-DSS. It's not telling you what information you need, but where you can get information using the tool that we are providing. So the tutorials are more how do you use the IFT-DSS tool rather than how do you do prescribed burn planning. Those are other places for that. But we have some of that information, and we also have, I've given a webinar which gives an overview. So these are tools that are available to you on a number of different topics within the system. And then we try to link wherever we can the actual literature or studies that have done particular analyses such as hazard analysis. What's cool is this will stay open, or in my opinion, what's cool is this tab will stay open, but you haven't gotten rid of the IFT-DSS. So you can then maybe you're working and you can go back and forth between the tutorial and your actual project on your own area. Okay. There's also, we have been trying throughout the system to incorporate feedback. I have traveled to people's places of work, conducted interviews with them on what they're trying to do, given demonstrations in a number of different formats on the system, and tried to get feedback from those folks on what's working, what's not, and then incorporate that feedback. But we also have this online feedback which opens up an email. You send this, it goes into the system, and it's looked at by about 3 or 4 people, including myself, depending on people's availability, and we evaluate, can we do that? Is that warranted? Is it within the scope? And sometimes it's just, oh yeah, we've got to do that because we've got something that is incorrect, and these people are pointing out, hey, this is incorrect or it's not working. And so this is really useful to us as we prioritize and work on fixing bugs and sometimes finding them. We test it as rigidly as we can, but people always find things. It's great. I mean, I really appreciate it because we'd rather have somebody come in, find it, provide us feedback than realize that something's been broken for a while. All right. So the last thing I'm going to mention on this before I go into the projects and start showing the demo is we're working on this collaboration tool. We've got it in-house. It's in testing right now, but this is a way to where you can work on projects with coworkers, publish things so people can look at and review. And we're at the initial stages of this, so we'll be looking for feedback on how we can improve it and what kind of things that you really need. So as you get on, get an access code from me, get on, work through using it to do some of the work that you need to do, meet your business needs. Also be thinking about and checking out on how can we improve it, because we really need that. And then again, if you don't want to go through the help, the instruction tutorials and videos are linked here just so you can get access to things. And you'll see that they're also linked throughout each of the projects. So as I mentioned, we're geared around projects, workflows, and runs, with workflows being the heart. But here's a set of projects that I've got already done. So these are my active projects that I'm working on. But for right now, I said I was going to go in and look at the tools, so the IFT-DSS tools. So I'm just going to set up a new project. So usually I fill out all of this other stuff, but you don't have to. It really helps when you come back. I'm going to go in by the workflows. And then you see I've got the workflows designed here. Under each of these tabs, there are a number of different tools. So, thinking about, well, under what conditions would my area ignite and burn to the level that I want? So you can go through and use the probability of ignition modules that are built using the Behave Plus algorithm. So the same algorithms that are in Behave Plus. Fire behavior, we have a number of different ways that you can calculate fire behavior. So using some of the functionality that you would see in Behave Plus, such as the crown or surface, linking the surface and size. So some of these tools that some people may be more comfortable with. But we also have, the minimum travel time. So looking at fire growth spatially. We've got FlamMap, the kind of basic run using the head fire on a landscape, but we're also running it on individual stands so you could compare, how does, say, a surface module that only uses Rothermill's surface fire behavior algorithm compare to a linked module that uses both the surface fire spread but then uses either the Scott and Reinhardt switch or the Finney switch to switch over and then use the crown fire equations. So we've got a number of different tools that you can go in, do some comparisons, identify whether or not you're going to meet your prescription needs or exceed them based on the conditions that you want to burn. And we also have some containment tools, spotting distance, safety zone, containment resources, fire size. So a number of these different tools that you can use for contingency planning, and then fire effects. And we have the two most common fire effects software platforms in the system right now, which is FOFM and Consume, and allow the users to go in and utilize these modules in a number of different ways, including linking to the digital photo series. So what I said I was going to do right now is get some land fire data. So I'm going to use the hazard analysis. Go in. I've mentioned that we have some tools in the hazard analysis, and I want to calculate fire behavior across the landscape. So I pull that in, and the first thing it says is, what data set do you want? So you can get a new data set from Landfire. You can utilize an existing data set. So, there's a number of different data sets. So, for example, if you went through, and this is what I would do if I was on, say, when I was on the Yukon Flats, I would just get as much data as I could for the flats, spend some time analyzing it, fixing places where I didn't think the fuel model was correct or things of that sort, and then I would just keep going back to that particular data set. But I want to show you how to acquire data from Landfire. Also, if you've got, say, an LCP file, this is what we allow you to upload right now, an LCP file. If you've got an existing one that you have spent the time to QC and you're really comfortable with, we allow you to upload that data set. So I'm looking at time. Yeah, I got 15 minutes based on my time frame. All right, so this is an area that near Petaluma, just south of me, it's called the Olimpoli, and I'm going to show you a risk assessment I'm going to run through really quickly on this area. So I don't want to use this area, but I can take and move around on this map and pick a different area. And I'm not restricted to using imagery. If you're more comfortable with a topo map, you can utilize a topo map. If you're more comfortable with a street map, you can utilize that. I'm going to use a topo map for this just because it has some of the information. Yeah, this is a good area. This is basically a slough, so it's a local nature preserve, and then there's a bunch of apartments around, so it's kind of a mix of open space and development wooey. So you can see when I go back to the map, here's the slough, here's a business complex. But so I'm going to grab some land here. I'm not going to get a big site because it does take longer the longer that you, or the larger area that you select. So I've got 6,000 acres selected here. I can go down. When I click on like that, it draws it down to 1 pixel. So I don't want 1 pixel. So I'm going to expand out again. And yeah, I'll do about 3,000 acres. So now, right now, it's going to our internal Landfire. This is the 2008 data. I have it defaulted to get the Scott and Bergen, but you can also access the earlier original data set that, was a refreshed 2005, or use the original Anderson 13. I had to move it over here because my screen is being blocked by the other stuff. So let's see how that looks. Yeah, you can still see it all right. So I've got a run name. You would probably want to take and make this run name a little bit more specific, but for this purpose it'll work fine. But so that when you come back in a year, now it says, okay, you sure you want to use that data set? Yep. So now it's building an LCP file. So it built an LCP file that will be used in FlamMap. I'm going to set some conditions. I'm going to make it kind of dry. So these are the basic inputs that you would give FlamMap. And I'll leave that woody moisture. And then I'm going to make it pretty windy. In this area, if you've been to Petaluma, this area of Petaluma is pretty windy almost every evening. So now I've set the inputs, but it's given me a chance to look at the LCP information. So I can look at this LCP information, evaluate whether or not I think, so right now the fire behavior fuel model, I could change it to the topo map layer if I wanted. I could change it to the street map. For evaluating the fuel models, I like to use the imagery. You can hide your layers if you wanted to make this bigger. So you can zoom out, zoom in, but you can also move this around, so you can keep that if you're going, well, what are these different things? And then you can bring back this. So right now I've got fire behavior model, fuel model, but I may be interested in aspect, or I may want to say, well, what kind of camera? Yes, that's perfect, because this should be, there's hardly any trees there, so canopy coverage should be low. But if I got in and I found out that my layer wasn't working as well as I'd want, and I'm going to pick a cheesy, for example, I might go in and manipulate this here to say that it's dry. Maybe it was late summer when this area is not quite as wet as what it's showing up on here. I may want to go in and alter that. So I could do that with a global way of editing everything. So change all fuel model from, say, short grass to whatever that I want. Maybe it's hardwood litter or something along those lines. So I can do an advanced edit, which changes everything, or I can do it pixel by pixel, which is what I'll do right now, just to show you one. So I'm going to change that from open water to short grass. Yep, I want to save it. So now you can see that within that spot, I have changed that individual pixel. And we've got some function now where you can draw a polygon around it and change all the information within the polygon area. So giving you the ability to basically change the data. So I'll save that. Yep. I'll get rid of this. Go back to the layers. I'm going to hit next. So this is running the FlamMap DLL to calculate surface fire behavior. While it's going through, so it's basically addressing the server, and it's run a fire behavior run for you. And then you can go through and do that same kind of analysis. The particular thing that it is defaulted to here is flame length, but you can go back and, maybe rate of spread is more important to you. Or maybe looking at, well, why is the rate of spread, so you can go back and look at the fire behavior fuel model. So there's a lot of really cool functionality in here that's easy to use and acceptable. You don't need to be a GIS specialist. You can get in, use it, and move on for the rest of your day. All right, so I'm going to get out of here. I'm going to go back to my projects. I'm going to get into a planned one. I have a few minutes left. I'm going to look at the risk assessment. And this is one, it takes a little longer to set up. It's still relatively fast and easy, but I could not do it in an hour. I could do it in a couple hours or less. But so I've got one that's pre-done, and I'm just going to go through each of the steps and kind of talk about the philosophy. So right here I'm at the run summary, but I'm going to go back here to the configure step. What we've tried to do is throughout each of these pathways, workflows through this, we've tried to explain what we're doing. So for example, here it says that this is doing the worst case flame length modeling, talking about potential benefit and loss, and then we provide the sources for where this kind of information is, and then there's model information here, which then provides links to the actual papers. It talks about what data set we had selected. I'm not going to hit this editor. I'll have to rerun the whole thing. And then a little bit about how the data is. There's also on each page a help session where you can look at what's a response function. And I'll open these up again. But for example, just here's the module information. That opens up the help, takes you to the module information. You can leave that open if you want to come back to it, but we just try to find kind of an idea, like a quick tips kind of idea. So next thing you would do is define your values at risk. We found that many times the values at risk are not available to the general public, but the local manager knows where they are. So we built some functionality that will allow you to either import a shapefile if you've already got it with the information, or what we have functional right now is create your own. And so this is one, if you remember, I went back and I, down at the Olompali State Park, we looked at developing a values at risk map based on the WUI, based on 101, and we created this polygon in the system and then labeled each of these. So the Burdell Open Space Preserve is here, the Olompali is here, and then things such as an airport, like I said, WUI, water treatment plant, so things that are in the general area. And you can again switch to the topo map if you prefer that. And we have some good instructions on like how to use the IFT-DSS to create this map. So you can again go to your help. There's a tutorial just on how to create the map, and it talks about different methods. We've got a freeform method, which so you don't have to stop and click at each place. You can use the mouse to draw your polygons. You can do the standard point and click that many people are familiar with, and all the way down through the processes you need to do to create this value at risk map. And this is proven to be really useful to a number of folks, and we're excited to get some other folks meeting in and testing it and evaluating if it makes sense for them. So then after you have your values at risk map, what you really want to do is evaluate what happens. I don't want to say how risky, but the idea about what kind of potential do you have to have a benefit or loss. So the first thing you would set up is you want to run flame map across it and evaluate based on flame length what kind of risk do I have of having an undesirable fire condition. And you can set all of your different values within the system based on what I've done. Then you run flame map, so it gives you a chance to, if you haven't already edited your data, if you have, so we'll assume that we have here, then you would run your fire behavior model. So what comes up as a default is from Randig comes the burn probability. So this is saying based on a ignition within that area, so a random ignition with anywhere within this area, what's the likelihood that an individual pixel would burn? So if we click on this, we can see that the likelihood is 4% that this pixel is going to burn. We go over here, that likelihood that that pixel is going to burn is basically 1%, so quite low. And it's 0 in some of these places, but we have to remember that what we input also influences this, because we're saying that we're having 500 random ignitions within this area, which you might want to put a few more in there. But we've also provided a scenario of a wind coming out of the west, a due west, at about 30 miles an hour. So these parts of the area are not going to burn as much because of it's less likely that a backing fire is going to reach these areas. So if an ignition starts, it's more likely an ignition will be in here, and so we get higher probabilities that the fire will burn. Like there's a 26% probability in this grassland that fires are going to get there with a flame length of 11.7. And it's within the Olompali State Historical Park. And I'll talk about what the response functions and things of that sort are just here in a second. Okay, so then when we look at that, we've set this response function. So we look at, here's our response functions. This is saying that everywhere that it's RF2, I'm going to get rid of this overlay because that's confusing things. So for example, here it's response function 7, moderate to strong loss. But up over in here, we've got, moderate to mild benefit to strong loss. Well, what does that mean? So you can go up to the help and look at the response functions. This brings up this Cochrane response function table, which allows you to set. So for example, response function 1, your fire is a good thing across the landscape. But response function, say, 12, fire is always bad. That might be your WUI interface. And you can use these based on your flame length categories that are set to weigh how your equation in terms of assigning risk is going to be used. For example, if it's always good at a low flame length to have fire in the system, at low flame lengths you'll get a strong, highly positive number. And so if I go back, I'm going to close a few of these. So I go back to our risk demo and I say, okay, that's the response function. Here's the relative change. We have this absolute number, and hopefully there'll be some questions on this because many times that's where things come up, and I've only got a few more minutes. But this red is where we have the greatest loss, least benefit. And there's two things at play here. It's a high probability that it's going to burn, but it's also got a high resource value. And that's a relative value. If you've tried to put money to these, sometimes that's much more difficult. And then you will want to classify, so you've got, maybe you're looking at it and you're saying that default of everything being classified equal, so 28%, 20%, 20%, 20% isn't right, and I don't have enough money to treat my whole area. I want to know where's my greatest loss, least benefit. And then I could put a high level, a high percentage of the area into this least loss, greatest benefit category because I'm not so concerned with those areas. And when you do that, you can then focus in your areas you want to treat. And then you may want to go in and play with this, and we've thought about this a lot. For example, this is all WUI. You may want to go in and say, well, why didn't it show up being all red in this WUI? I definitely don't want any fire there. But it could be that based on this scenario we ran, that this area wasn't very likely to burn. So again, it's based on the burn probability multiplied by the value that's at risk. So if it was a high value at risk but a low probability, you get a low number. But now when we've run this same scenario with a north wind, so wind coming out of the north, this whole area where it's WUI then becomes red, and you would think about, well, maybe I need to do some treatments in this general area. And I'm going to go just mention really quickly, you can see this area here where the risk becomes quite high. That's because based on the modeling there are some trees right here that indicate that it would jump across the road. And if we look at when we start analyzing and doing some analysis on the area, we get a basic window where you can see the fire moving right through this particular hole. And so then all I'm going to do on the prescribed burn for right now, because I think I'm a little limited on time, is just show a plan that in our system we have a module for each one of these templates. So some of them are not filled out by the user, but each one of the elements, there's a tutorial on how to do this. But you go through and complete each element, and when you get to the end, you can produce this templated document. And we have some mapping capabilities, so you can insert maps. I'll show you. I'll download one real quick before I pass it back to Josh for questions. But then you can insert the maps into your system, so you can populate your prescription. So element 7, insert the maps where needed within the system, and it hopefully this will spike your interest into going in and checking out how to use some of this functionality. And all I'll do right now is export the map. So this is saving it as a map image. Each map that's created can then be saved, produces a PNG file with an arrow, which it can then be used in your burn plans or any of your other documents to show why you did something. And I'll stop there.
All right, thanks, Stacy. You covered a lot of ground there in a very efficient amount of time. That's pretty impressive.
Well, I told you that's just a think of that as a finger sandwich of what's actually in this.
All right. Well, we've got a few questions that have come in already, and I encourage everybody to get your questions in, and we'll try to get through all of them. The first question comes from, and hopefully, Eric, I don't script your last name, Eric Torres Jaquez, and he asks, how does IFT-DSS differ from Irwin, and how will it interact with other systems such as WFDS, etc.?
That's a great question, and I'm not as familiar with Irwin as I'd like to be. I was at a meeting where Irwin was discussed. Irwin, as far as I can tell, is not a scientific modeling framework where you can go in and run the different models. It's more of an accounting system of looking at the fire detection. We would like to understand more about it and link to it. We are in a lot of discussion with people about how do we pass data back and forth with systems such as WFDS or the Blue Sky framework, so that we've got one thing we're working on right now is we pass emissions data into the Blue Sky framework. It then runs a smoke dispersion scenario and provides some maps of where smoke is likely to go given the modeling scenario that you're using, and then we get that data back from the Blue Sky framework, and you can then use that in your burn plan document or your fuels planning document. So we're really working on that. We're very highly encouraged about being able to pass data back and forth between WFDS and IFTDSS, Blue Sky framework, connecting to things such as Irwin. There's a big push to do that kind of thing, so that's really cool that everyone's moving forward in that direction.
Okay. Next question is sort of related. John Washington asks, do the models effectively talk to each other, or are the limitations of each model compounded as the process progresses?
Oh, great question. They talk to each other in terms of if the appropriate data that comes out of one can then go into another, then we allow that to happen. And we don't have any data in IFT-DSS to show this yet, but that's getting at that idea of how do we analyze how the models are working. But I've been working on another project called the Smoke Modeling Intercomparison Project that we just finished up, that did look at, based on alternatives, how our tendencies in one model, say consume, passed on from fuel consumption. So, and even going one step forward, you're detecting your fire, so how big is your fire influences how much fuels are available to burn. So then whatever fuel loading map you have also influences how much fuel is available to burn. Then whatever fuel consumption model and emissions factors you use influence that, and you can get widely different values based on the choices that you make at each step in a pathway such as what we're talking about here.
Okay.
And that's where guidance is needed.
Next question is from Bob Watson sounds like he's having some login issues, but he says it came up on my screen that I was logged in under a different name. I should be logged in as Bob Watson. I'm not sure if you want to respond to that or just talk to him offline about login issues there.
Yeah, that surprises me. Could he take a screenshot and email that to me, and let's do that offline? That shouldn't happen.
Okay. Next question is from Kevin Mundorf. How are weather variables entered into this model, auto-updated or manually?
They are manually entered, and we are working right now to incorporate the functionality from Fire Family Plus in. Remember that this is not a operational tool, this is a planning tool. So we're not trying to say, like, today, have you open it up and today it gives you fire behavior potentials. We are saying if you're planning a prescribed burn or a fuels treatment, how 6 months from now or in June, well, I wouldn't be 6 months from now, but how in the future would fire behave? So we're trying to look more in terms of planning for the, how do I say this, planning for doing the documentation and setting up your project. It would be interesting to have it to where you could click on it and it have it update the latest RAWs information and then run it out, and you could use that for kind of short-term operational planning. We have not gone there yet and have not had funding to do that. Could be done though.
Okay. Allison Coons asks, is it possible to load our existing fire management units from WFDS into, let me try it, IFTDSS? Did I get that right?
Yep. If it is definitely possible, I'm thinking of how big a fire management unit is in general, but if it's less than 3 million acres and right now it's in the form of an LCP, yes. We may want to talk and see about what other kind of ways that they want to incorporate it, and then we could work on getting some time and money to do that, because we're unlimited in what we can do. But right now you can take in, import an previously built LCP if it's been built in WFDS, as long as it's under 3 million acres.
Okay.
Or 2.7 million.
Okay. Next question is from Ann Burkholz. When will new burn plan templates be incorporated and available?
As soon as we can, and I'd like her to go in and look at the burn plan template we have in there now and see if that does not meet your needs. We're working on discussing the changes we may need, which seem to be fairly minor, to address the changes that the FMC has made in the new burn plan template. But I encourage her to go in and take a look at the particular information that we have in the burn plan right now, because I think she'll find some stuff that'll be useful.
Okay. Holly Kleindienst has a comment. Thank you. IFTDSS has come a long way since the last time I saw it.
Yep.
And Ryan Elliott asks, is there any planned functionality for the ability to model a point ignition in a planning area for a prescribed fire to assess the probability of escape for a given project or day?
Yeah, we don't have, the functionality is there to do that, but we don't have a specific workflow that said, that is exactly what you're doing. But the functionality is there, and I would encourage him to get in and talk to me about how we would do that. But we have the functionality to model a point ignition within an area, and you could then identify where potential areas for escape would be. That's really what we're hoping people do for the hazard analysis in particular, but you can then use that for contingency planning. The last couple of years I went to a number of different burn boss evaluations, escaped fire evaluations, and one of the things that it seemed like we could help would be to identify those areas, not only because people pretty much seem to know what's inside the area that they're burning, but sometimes they lose track of what's around the area or outside the area, and that's that we feel like we have a tool that will be very useful for contingency planning in that way, shape, or form. Hopefully I answered the question.
Okay. Holly Kleindienst actually has a question I should have read down. A couple of people have made comments there. Sorry, I'm not scrolling down there. Is the intent that we could use this to analyze one alternative versus another as we did with informs?
Yes. That was the easy answer. Yeah. In multiple different ways, and looking at different winds and different, yeah.
Okay. Bob from Oregon wants to know if it's Mac friendly.
People are running it on iPads. I'm not a Mac user, but I know that it runs on an iPad. It runs on my smartphone, but I'm an anti-Mac person. I got a Droid, but yep, it works on Macs.
Okay.
But people are running it on iPads, which surprised me the first time somebody came up in a class and said, "Look, I'm running it on my iPad right now."
Okay. Heath Cotto wants to know if FS Pro is going to be added to the system.
I sure hope so. We will have to make those priorities, but based on the WFDIS tools that we don't have inputted right now, FS Pro makes a lot of sense for when we move forward.
Okay. All right. Well, that is all of the questions that we have there. So first off, Stacy, I want to thank you. It was very interesting, and I know it's a complex system, and you did an amazing job of condensing it down into a nice condensed presentation. So yeah, I appreciate that.
Thanks.
We're going to have the webinar is being recorded, and as soon as we log off here, I'll be uploading it to Advances in Fire Practice, and the link will be on the Advances in Fire Practice page by the later afternoon, so you can pass this on to anybody you like, and it's on the Wildland Fire YouTube channel is where it's stored, and it'll be available forever as long as YouTube exists. So you can take a look at this again or pass it on to anybody you know that might want to do it.
Yeah.
And go ahead, say
let me send can I send this will this go to everybody? If I send this is it only went to organizers and panelists, but that's the website for the people that haven't got in.
If you can send it again, you can send it to the editor. I'll try to do it.
Okay. And I encourage everybody to get on.
Send to the entire audience. There we go. Okay. So yeah, there's the link, iftds.sonomatech.com.
Now we've got it here on our system now, but we're looking to move it over in the future. But we'll be staging it for a while, for the next couple of years probably.
Okay. All right. One more question just came in just before we log off. Is there a user load limit on your processors and servers?
Theoretically, yes, but we don't know what that is. We've had a lot of people on it at the same time, so yeah, we haven't been restricted by the number of users on the system yet.
Gotcha. All right, Stacy. Well, once again, thank you, and we'll see everybody next time, or listen to everybody next time. Thanks.
Thanks, Josh. This was great.